This is section 6.1 continuing on with the inverse sine function. This is on page 6-2. So the inverse sine function is y is equal to inverse sine of x. We can write it like that, or we can write it as y is equal to arc sine of x. And what it means is that x is equal to sine of y. Do you see how the x and the y are switched from here and here because they are inverses of each other? There's also a restriction on y, so let me explain that first. If we look at the graph of f of x equals sine of x, is that a function? Yes, it is, because it passes the vertical line test. Is it one-to-one? It's not one-to-one, because do you see how it does not pass the horizontal line test? If I draw a horizontal line, you can see that it passes the graph at many places. So this is not one-to-one. What we're going to do is restrict this graph so that we can make it, just a part of it, be one-to-one. If we take off the part from negative pi over 2 down, and then from pi over 2 up, so just this piece of the graph, does that pass the horizontal line test? Yes, it does. And if we go any further out to the right or to the left, it's not going to pass the horizontal line test. So we are going to restrict this graph so that x only goes from negative pi over 2 to pi over 2. So the domain is going to be restricted from negative pi over 2 to pi over 2. Now that's for the function f. The range goes from -1 to 1. If we look at the inverse, do you remember how you switch the domain and the range? The y is between negative pi over 2 and pi over 2, because this y here, this is for the inverse function, because the x and the y are switched. So if you want to go back up and review that, remember you just switch the domain and the range when you're going from a function to its inverse. So we can think of y equals inverse sine of x or y equals arc sine of x as y is the number or the angle in the interval whose sine is x. Y is an angle, and we're taking the sine of that angle to give us x. The domain of sine inverse is the same as the range of the original function, so that goes from -1 to 1. And then the range of sine inverse is the same as the domain of the original function, so this goes from negative pi over 2 to pi over 2. The inverse sine is the inverse of the sine function. We had to restrict the domain of the sine function so that it could have an inverse. We had to choose a piece of it so that it would be 1-to-1. I'm going to go ahead and go through example 1 because the other video doesn't show you the unit circle. I think it's very helpful to have that unit circle in front of you when you're doing your work. Example 1, we want to find the value of each real number y if it exists. So the first one, I'm going to rewrite this. We're going to think of this as the sine of what value y gives us 1/2. This means the same as this original problem. So we're thinking of an angle. What does y have to be in order for sine to be 1/2? Well, the definition of sine on the unit circle is y. What we want to do is find when the y value is 1/2. Now we have several answers, and we actually have an infinite number of answers if we didn't have a restricted domain. But if you look back over here to this piece here, this is very important. Y has to be between negative pi over 2 and pi over 2 when you're dealing with arc sine. Where is negative pi over 2? Well, that's coterminal to 3 pi over 2, and it goes up to pi over 2, which is up here. So what we're doing is we're looking at quadrants 4 and at quadrant 1. So in quadrants 4 and 1, where is the y value 1/2? Well, that would be right here. So if the y is 1/2, well, what is the angle in radians? That's pi over 6. So y is equal to pi over 6. The second one, again, we're restricted to this range from negative pi over 2 to pi over 2 for the inverse function. I'm going to rewrite this. Sine of some value is equal to -1. This means the same thing as the original problem. So we look for a y value that is between, and it has to be either in the fourth quadrant or in the first quadrant. So where is y -1? Well, you can see that's down here. Now we're not going to write the answer as 3 pi over 2 because it has to be between -pi over 2 and pi over 2. Well, 3 pi over 2 is coterminal with -pi over 2. The answer is -pi over 2. When you're finding the arcsine of a number, you're always going to have just one solution. Remember, this is a one-to-one function. Sine of y is equal to -2 for part C. Are there any values of y, because the definition of sine is y, any values of y on the unit circle that are equal to -2? Oh, if you see that, that's not possible because the lowest we get is -1. You can look back here at the domain of the inverse. It only goes from -1 to 1. -2 is outside of that domain, and so it doesn't exist. Moving on to 6-3, the top of the page we have a graph of the arcsine or inverse sine. I'm going to rewrite this equation using sine instead of arcsine, which means all I have to do is switch the x and the y. X is equal to sine of y means the same as what we have here, except for the restrictions. We have to watch out for that. If we look at the f of x is equal to sine of x graph, remember how we restricted it from -pi over 2 to pi over 2 so that we have a one-to-one function. To graph this graph that they have here, they just took values that were on this graph here and just switched the x's and the y's. So the real obvious one is 0, 0, and you can see that here. They have -1, -pi over 2, and you can see that here we have -pi over 2, -1 is this point. So you're just switching the x and the y. Let me show you again how we can get this on the unit circle. Remember, the definition of sine on the unit circle is the y value. We're finding out, if I look especially at this one, it's easier. So x is the sine of something. So sine of what gives you -1? Well, if we look here, we're restricted from -pi over 2 to pi over 2. So coming up in the fourth and the first quadrants. If we have -1 for y, you can see that the angle is -pi over 2. That's coterminal with 3 pi over 2. So y is the angle. If the sine function is equal to -√2 over 2, that's this value here, then you see how this is 7 pi over 4? The problem is that 7 pi over 4 is outside of the range of arcsine, and so we have to subtract 2 pi, so it gives us -pi over 4. √2 over 2 is up here in the first quadrant, the y value, and so you see the angle is pi over 4, and then when the y value is 1, then the angle is pi over 2. So that's using the unit circle, or you can just switch the x's and the y's on this part of the graph of the sine function. Now looking at the inverse sine function, the domain, we're reading that from left to right. You see how we're going from -1 to 1. And then the range, we go from -pi over 2 to pi over 2. And I think of all things that you want to remember, because there's so much to remember, is this range. If you can remember that, it will help you so much in the homework. The inverse sine function is increasing on the open interval from -1 to 1. And it's also continuous on its domain, including the endpoint, so from -1 to 1. The x and the y intercepts are both 0, 0. You can see that on this graph. The graph is symmetric with respect to the origin. So the function is an odd function. For all x in the domain, the inverse sine of -x is the same thing as negative inverse sine of x. Now let's look at the inverse cosine function. It says y is equal to inverse cosine of x is the same thing as y equals arc cosine of x, and it means the same thing as x is equal to cosine of y. So if we switch the x and the y values, then we have the inverse. And here our y is going to be between 0 and pi. Let's look at the cosine function. You can see that it is a function. It passes the vertical line test, but it's not one-to-one because it doesn't pass the horizontal line test. But if we restrict the domain of this function to between certain values, then we can find an inverse of just that piece of the function. I'm not going to choose from negative pi over 2 to pi over 2 because do you see how that would not pass the horizontal line test? Instead, we're going to go from 0, so this part of the graph, to pi. So from 0 to pi, do you see how this piece of the graph in between here, this passes the horizontal line test? So we're going from 0 to pi in the original function, and I'll go ahead and write that here. So we're just going to take the domain from 0 to pi, and then the range goes from -1 to 1. We'll read it from bottom to top. Remember, for the inverse function, we're just switching our x and y values. The domain of the inverse is -1 to 1, and the range is from 0 to pi. Coming back up here, we can think of the inverse cosine, or the arc cosine of x, as y is the angle in the interval from 0 to pi whose cosine is x. So I'm going to help you a little bit with the example 2 with a unit circle because I think it's easier to look at it that way. So you want to remember what the range is. This is really important. The inverse cosine function goes from 0 to pi. So what we're going to do now is look from the first quadrant onto the second quadrant. So from the first to the second. Our values of y are going to be angles that are between 0 and pi. Let's find the inverse cosine of 1. I'm going to rewrite this as cosine of y is equal to 1. So we want to find on the unit circle, the definition of cosine is x. We want to find an x that is 1. Oh, that's right here. So when x is 1, what is the angle? Well, the angle is 0. So y is equal to 0 radians. Here we have cosine of y is equal to -√2/2. Definition of cosine is x. We want to find a value of x that is -√2/2. So that's here in the second quadrant. And then the angle is 3 pi over 4. So y is equal to 3 pi over 4.